In this example, we assume that all variables represent positive real numbers, and we need to simplify the square root of 72x cubed y to the 5th z to the 18th. If you notice, everything underneath this radical is all multiplied together. It's one big product. So we're going to have to use the product rule for radicals that I've written here. And this rule says if you have the nth root of a times b, it equals the nth root of a times the nth root of b. Notice this works if we have a product here, a multiplication. It doesn't work if you have a plus b or a minus b. So in our case, we have a square root, and what number do we not write up here? We're too efficient to write. We know that in our case, n equals 2. So for square roots, we know the square root of a times b is the square root of a times the square root of b. I'm going to use this property to simplify my expression, but before I do, I want to simplify the square root of 72 by factoring the 72 into perfect squares and non-perfect squares. There's lots of different ways to factor 72. It doesn't matter which way you go, you'll land up at the same answer in the end. Well, I'm going to pick 72 is 9 times 8. 9's a perfect square, leave it alone. 8 is not a perfect square, so factor it again. You get 4 times 2. 4 is a perfect square, leave it alone, and 2 is a prime number. So what I'm going to do is I'm going to write my 72 as 9 times 4 times 2. So I'm going to rewrite my expression. So I'm going to have the square root of 9 times 4 times 2 times x cubed times y to the 5th times z to the 18th. And now I'm going to use my product rule for radicals, which results in the square root of 9 times the square root of 4 times the square root of 2 times the square root of x cubed times the square root of y to the 5th times the square root of z to the 18th. We normally don't write that step, but I wanted to break everything down for you as much as possible. Now we have to simplify each individual part. Well, the square root of 9 is 3 times the square root of 4. The square root of 4 is 2, so I'm going to get 3 times 2. Can we simplify the square root of 2? No, so 2 stays under the square root sign. Notice I left a little room here, and I'm going to have the square root of 2. Now, how do I figure out the square root of x cubed? I'm going to do it by the shortcut method, which uses the index. And what index are we too efficient to write up here? A 2. The shortcut method says you take the index and you divide it into the exponent on the variable. So 2 divides into 3 one time. 1 times 2 is 2. Subtract. I have a remainder of 1. The quotient is the exponent on that variable outside. So I'm going to have x to the first power outside the square root sign. The remainder is the exponent on that variable underneath the square root sign. So I have x to the first outside times and also x to the first inside the square root. Now I'm going to repeat it for my y's. Remember, I have a 2 as the index. So 2 divides into the exponent on the y's is a 5. 2 divides into 5 2 times. 2 times 2 is 4. Subtract 5 minus 4 is 1. 2 is the exponent on the y outside. So I'm going to have y squared outside of the square root. And the remainder of a 1, y to the first power inside. And lastly, I need to look at the z's. Well, again, my index is 2. 2 divides into 18 how many times? 9. 9 times 2 is 18. Subtract, is there a remainder? No. So I'm going to have the quotient of 9 is the exponent on the z outside. So I'm going to get z to the 9th power outside, no z's inside. So now all I have to do is neaten it up. 3 times 2 is 6. We never write x to the first power. We just write x. Y squared z to the 9th times the square root of 2xy. So that is my answer.